continuing our study of vertex form of parabolas. We've got an example that has a little bit of everything in it. So I'm going to start off with, again, the traditional transformations here, the translations I should say. So our graph is going to be translated to the right 3 units. Remember, it's the opposite of the positive and negative sign that we see inside the parentheses for that horizontal movement. So we're going to be translated right 3 units. And then we have a vertical translation thanks to the +2 there. So we're going to be up 2 units. And so that there gives us our vertex. So we can right away jump to that. We can go to the right 3. We're going to go up 2. And I'm going to go ahead and plot that point right away. To the right 3, up 2. And I've got my vertex. Now we have to deal with the -1/2 that's out front. So first of all, the fact that it's negative is separate from the 1/2. The negative sign means that we're going to be reflected across the x-axis. So that means for us our parabola is going to be opening down instead of up. So we're going to have a downwards facing parabola because of that negative sign. And then separately we've got that 1/2. So our graph is dilated by a factor of 1/2. So that means this parabola will be moving in the vertical direction half as much as it normally would. So we'll demonstrate that using our typical pattern of points and then show what actually transpires. So we know this graph is going to go down instead of up because of the reflection, but we'll deal with that 1/2 in just a second. So again, under normal circumstance, if it was just a reflection from our vertex here, we'd go left and right 1 and then down 1. We would go left and right 2 and then down 4 from the vertex. So that would put us about here and here. Left and right 3 and down 9 from the vertex. So that would put us about here and here. So if there was no 1/2, if there was just a negative sign, that would be the collection of points that we would use to sketch our graph. But, and I'll switch to blue here, we do have this 1/2 here. We do have this dilation factor. So our left and right movement is still going to be the same, but our vertical movement is going to be cut in half. So instead of going left and right 1 and down 1, I'm going to go left and right 1 and only down 1/2. Let's see if I can actually get those to be roughly 1/2. That looks a little better. Then we're going to go left and right 2, but instead of down 4, I'm going to go left and right 2 and only down 2 from my vertex. That's going to put me here and here. Left and right 3, I'm not going to go down 9 from my vertex. I'm going to go left and right 3 and only down 4.5. Again, half as much. So I'm going to count 2, 4.5. So that puts me right about here and here. So we can see compared to our regular graph, we have a little bit wider parabola as a result of that 1/2. Or the way to think of it is it's not going down as fast as it otherwise would because of the presence of that 1/2. Now, domain and range, like we looked at in the previous example in the previous video, for the domain, we're still going to be all real numbers because this graph continues to move to the right and left forever. This parabola never goes vertical. It keeps on getting wider and wider. For the range, now we have a highest point instead of a lowest point, and so whatever that y coordinate is going to be our maximum value. So we're going to have y, this time it's going to be less than or equal to that y coordinate of 2. So our range is all y values below 2. The last thing I wanted to revisit was something that we did with the absolute value functions, where we're taking some information that's given to us about our parent graph, our parent function f of x, that we have some new function g of x that's the result of some changes, some transformations being applied to that original function, Then we have our two ways of writing the function, in terms of x and then in terms of f of x. So in terms of x is when we're specific to this function x squared, and then in terms of f of x is when we're keeping it general to where we might not even know what our function was. Might be absolute value, might be x squared, might be x cubed, might be square root of x, and we're just going to write it in this general format. So I'll undo that x there. So in this case, we have two translations. Our graph is being translated down 7 and to the left 4. So if we want to write that in terms of x, what's more familiar for us, we can say that g of x is going to be equal to, now there's no dilation or reflection, so it's just going to be x squared, but I have a horizontal translation, so in the parentheses with the x being squared is that 4 units to the left, so we know that it's the opposite of the positive negative sign that we would expect, so that's why I have plus 4 there instead of minus 4. So normally we would think of 4 as being 4 left being negative, but in our equation it's going to show up as positive. And then we have a translation of 7 units down, so that's going to track with the positive negative sign that we expect on the outside, so we have this minus 7. So then we will also want to write this in terms of f of x. So I'm still going to have g of x here equals, and so now instead of having it be with the x squared here, I'm going to write it in this f of x format. So again, on the inside, just like I had here, I've got f of x plus 4, because that horizontal translation affects the input, and then minus 7 for that vertical translation downwards is separate from the f of x plus 4. So again, in this format here, the idea is we might be affecting any of a number of different types of functions in the exact same way, translating it to the left 4 and down 7. Here, it's very specific to a parabola. So if we try that one more time down here in the last example, so now we have a new function g of x that's the result of taking this x squared function, and we're going to dilate it by a factor of 4. So that means I'm going to have a 4 out in front multiplying an x squared if that was the only thing that was happening. We also have a reflection, so I'm going to have a negative sign out in front here to go with the 4. And then finally we have a translation up 5 units. So when we're translating in the vertical direction, like what we saw here, it's going to be outside of the x squared, so I don't have to squeeze anything in with the x and square it. It's going to be a translation up 5 units, so I'm going to have a plus 5 tacked on to the end. So then if we want to write that in terms of f of x, so if we didn't know what our original function was, but we wanted to still indicate these exact same 3 transformations, the dilation, the reflection, and the translation up 5 units, it would be negative 4 times, instead of x squared, it would be just f of x, and then plus 5. So all we're doing when we're writing something in terms of f of x, we're just going to have f of x in our expression over here, or if there's a horizontal translation, we might have something added or subtracted to the x on the inside, but it's still f of the input, x plus 4, f of x, whatever it might be.